Mean. Average. Okay, so this is, oops, there's an A in there. So average value, mean value theorem for derivatives. The derivative represents what? On the slope. Slope of tangent. And then we've seen this formula, f of b minus f of a over b minus a, lots of times. That's slope of. This is that's why this says mean value. So there's a couple ways that we can express this. We'll think of this equation. The f of b minus f of a over b minus a, that's your average velocity, right? Displacement over time. Also known as slope of the secant. So what's the important parts to the mean value theorem? Well, you need to have a continuous curve on a closed interval, and it must be differentiable. If that's the case, so here's a picture.
What's the test for differentiability?
You tell me. What's differentiability? Has to be continuous, which it's already stated there, but it can't have what? There are 3 other places where you can't have something differentiable. So corner, cusp, vertical tangent. If it has one of those things, then we cannot apply the mean value theorem. Okay?
So is that something where we have to test before if it has?
Yeah, you have to make sure. So not the first example, but on the next page it'll say, I think it says, or maybe it does say in this example, but they'll ask, does the mean value theorem apply? So you're going to look at it and you're going to ask yourself, is it continuous? Is it differentiable? If you can say yes to both of those, then you can apply the mean value theorem. Yeah, on the next page. We'll see. So basically what happens when slopes are equal? You get parallel lines, right? So basically what this theorem says, if you take any curve that is continuous and differentiable, let's say on a closed interval, so here's A to B. So if we connect these, we have a secant line, right? So this theorem says somewhere in between these 2 points, I have to have a tangent line that's parallel to that one. Okay? So let's take a look. So example 1, I do have here. State whether the function satisfies the hypothesis of the mean value theorem on the given interval. Okay, so we're just looking at specifically from 0 to 2. Is it continuous? Does it have any corners, cusps, or vertical tangents? No, so first we'll say yes. And we're going to abbreviate just MVT. That's mean value theorem. Okay. Right. It's continuous and differentiable. That's how we know. All right, now that we know it applies, here's the formula. Now, C, if you don't like to use the letter C, just remember C is just an X value. It's just one of these cases where you remember when we would do like the limit definition and we'd use A, and I'd say, well, you can really just keep it as an X. It's your choice. So we want to find a value of C somewhere between 0 and 2. So we have to make sure that it ends up being between 0 and 2. So if we get a number like 3, then that doesn't work, okay? Where the derivative of this is equal to the average slope. So what's f? So we want to set f prime of x, which is, what's f prime of x? 2x. We want to set this equal to f of 2 minus f of 0 over 2 minus 0. Here's our a and our b. So I have 2x equals, what's f of 2? 4, yeah, plug back into the original. So 4 minus 0 over 2. So we get 4x equals 4. X equals 1. What's
yes,
wrong?
but no. It's 2x is equal to 2. But still x is equal to 1.
Oh, you just crossed it.
Oh, yeah. Sorry.
Okay.
That was a weird way of doing it.
I didn't even think about it. And it's not like I did this problem yesterday or anything. But yeah, it both works. I didn't even think of, I did it that way yesterday.
Anything
That's
just
pretty funny.
simplifying the form of the
No, that was too complicated in that moment. All right, so is 1 between in our interval from 0 to 2?
Oh, yeah, it is.
Yes.
What if it's not?
Then either we made a mistake somewhere here, actually, or the mean value theorem never applied in the first place, and so we, yeah, so if you get a number that's not in here, that means you either made a mistake here, or the mean value theorem shouldn't have applied in the first place, okay? Because that could happen where you don't, and then if you get something, you know you made a mistake somewhere. So, next one. Does the mean value theorem apply? Well, what does this graph look like? A V.
But up 1.
So it's up 1.
Yeah, so there's a corner.
Okay, so I want to look at from -1 to 1. So I'm just looking at this part of the graph. So it's continuous. Is it differentiable? Not differentiable. So mean value theorem does not apply because it's not differentiable at x equals 0. And how do we know that? Because we could see that there's a corner. Good. So we're done. Okay, we don't have to do anything. We just say that the mean value theorem doesn't apply. Done. Now, quick question. What if the interval was, let's say, from 1 to 3? Would the mean value theorem apply? Yes.
How do you find a vertical tangent? If it's just a line.
What do you mean? How would you?
I mean, how do you? I mean,
That-
the would just be this. Oh, okay, right. There's no
You-
curve, that's it.
Right, so it's not, that's why we say at a vertical tangent it's not differentiable there. So this theorem won't apply. However, if I just shifted over the interval so that the corner wasn't included, then the mean value theorem would apply. Don't worry, I won't, that would be like a trick question. I wouldn't do that. So you'll either be given something that is differentiable, or it'll have a corner or cusp, and clearly it's in that interval. So, okay. Let's see. All right, so does the mean value theorem apply? What does this look, do you remember what this looks like? So ln goes like this. So is that continuous? So we're looking from 0 to e, so like about here. Is that continuous and differentiable? Just on the blue section here.
Yeah.
Yes.
try this every time?
Well, no,
Okay.
I'm writing it out for your notes, but like if this was a question on a quiz, it circle yes or no. Okay, you don't have to like say it applies because blah, blah, blah. I mean, on the AP exam, they would have like a multiple choice question and they would give you like a function and they would say, it's continuous but not differentiable, it has this or that, and they'd give you like a whole bunch of different options to choose from, which makes it much more complicated. I'll just ask, mean value theorem apply? Yes, or circle no.
Is the whole AP test multiple choice?
There are 45 multiple choice and 6 free response.
I have a question.
Mm-hmm.
Might make you very mad. But
Oh.
I'm confused. I don't get how to look at it and tell if it's differential. Like, I only know like when we do the equations.
Okay, so first I look to make sure that it's continuous. Doesn't have any holes, it doesn't have any, just from here to here, okay? Then, so I can see it's continuous. Now I look for, does it have a corner?
I don't get how to look at it and see this.
So a corner would be like a change in the slope, like with the absolute value, like it came here and here, opposing. And then the answer to the vertical tangent and the cusp are very specific. Remember the cusp was even over odd? There's nothing in the equation that shows us that. And for vertical tangents, it's odd over odd. It's an ln.
Looking at this corner.
Okay, so what's the derivative for ln? 1 over, so 1 over x plus 1 times the derivative of x plus 1, just in case we had to do chain rule, but it's just 1. So we want to set this equal to, so it's going to be ln of e plus 1 minus ln of 0 plus 1 all over e minus 0.
Wait, minus what? Minus ln.
Oh, why did I put f? Yeah, I wanted to put ln in front. There we go.
I have a quick question.
Yeah.
Just for finding the derivative of the first part, ln of x plus 1.
Yeah.
It's the formula is like 1 over
Whatever you're doing times the derivative of that
times the
one.
derivative of u, right? Okay.
Yeah. So I have 1 over x plus 1. Now, ln of e plus 1, that's not something you can like distribute, okay? It's not like you could do ln of e plus ln of 1. ln doesn't distribute, it's a function. So we just leave that. What about 0? What's ln of 1? 0. And what do we have in the bottom? Just e. Now this could get really complicated in terms of, like if you were trying to cross multiply, I wouldn't bother with that. I would take the reciprocal of both sides. So x plus 1 becomes e over ln of e plus 1. And then I just have to subtract 1. Now, we can get,
Why don't we just type in ln e plus 1 and I'll go to
yeah, well that's what we're going to do. It's just, let's say you didn't have a calculator and you had to simplify this as much as possible. This would probably be your easiest approach. At least I think it would. You could cross multiply, it'll still work.
E or what? Just like
E. E. Just
Yeah,
E.
like, you plug in E.
There's two places. Well, you could either type in a 1 or there's the E button on your calculator.
Yeah, I have no idea.
Oh wait.
You have 2 different E's.
Oh yeah.
Look at your calculator.
I only knew that there was e to the x. No, it's not. ln is
Okay, there's 2 E's. Do you see right where the division sign is?
Oh my
There's
God,
an
no
E.
way.
here.
You have
I've never
second
seen that.
divided by just gives you an E. The one where it's second ln gives you e to the power.
That's so weird.
Crazy.
Crazy. It's an option. It's a real option.
Well,
Whoa.
that makes sense because e is an
Stop.
actual number, but
This is too much for me.
Stop it.
This is too much? See, then you don't have to go through the process of typing in a 1 as your exponent.
I'm terrible at that.
wow. Say 3 1
I got like 1.07.
No, I tried.
Truncated.
1.0699. That is between 0 and E.
If you, what do you mean? If you truncate, then you don't need the last 9. If you round, it's going to be 1.07, because remember when you have 2 not, it's going to round up.
Or also, we can just put
Truncate
3
3 or
values
4.
in after the decimal, right?
Yes,
That we're supposed to do.
you can truncate or round. Both are fine.
Truncate.
Yeah. Okay, so your answer would be,
Okay. That's it.
those are both fine answers. This is rounded, this is truncated. Good? Okay. Interpreting the mean value theorem. So what does that mean, like in a practical application? So let's say you're in your car, you accelerate from, you're at rest. It takes 8 seconds to go 352 feet. Okay? So that means that your average is 30 miles per hour. 32 over 8 feet, so 44 feet per second, or 30 miles per hour. So that means at some point while you're driving, your speedometer has to read exactly 30 miles per hour. Like you could go faster, you could go slower, but if your average is 30 miles per hour, at some point it's got to be 30 miles per hour. You can't jump from 29 miles per hour to 31 miles per hour. It's got to, because it's continuous.
Yeah.
That's all that says. There are other practical applications we get into later on. So, okay, this is going to look a lot like we did in the last section. So, increasing and decreasing, we'll just start off with some review. What did you do last year with increasing? Yeah, this is really easy. How do we know where it increases? Where slope, positive slope. So, like right here. So, from here to here. So, we're going to say from -2 to 2. Now, I'm using brackets because most calculus books will use brackets. Just so you know, there are a couple out there that believe it should be parentheses. I'm fine with either one. The AP exam, so it's interesting, the AP exam uses brackets, but they will accept parentheses.
But parentheses would be more correct since M would be 0. At 2 and -2.
They include the endpoints for whatever reason.
Do you agree with that?
Yeah, actually I do. Because
Is it like math?
from that point, it's increasing. And it increases right, the point is included. I know. Here, same thing. So from -2 to 2, or if you want to write parentheses, that's fine. So we actually did this last week with the increasing, finding the local extrema. We did all those steps. Remember the number line with the pluses and the minuses, and we drew in the arrows? So I introduced that earlier than the book does because I just think it makes sense, because increasing and decreasing tell you where your maximums and minimums are. Like if it goes up and then it comes back down, you know you have a max. So what does that mean? Well, we did this. We did this on a number line. When the derivative's greater than 0, the function's increasing. If the derivative's less than 0, f is decreasing. Okay? That's real simple. So I'm going to refer back to, what page was that? This page. Okay, so taking a look at the next example, we're going to follow these steps because, so I just scrolled back. This is on page, what page is this on? This is page 9 of your notes packet, or no, sorry, page 5. This is on page 5 from your notes. I'm going to keep the steps up here while you're looking at the next example. So what do we have as our first function here?
X squared minus 6x minus 12.
Okay, so first thing I want you to do is think about what's the domain. Okay, so we're going to write,
When it's a polynomial, it's always
when it's a polynomial, it's always all reals. So here, oops. So our domain
Can I put the all rules in there?
Yeah, that's fine. Okay, so step 2. There we go. Find the critical points. And then we want to make sure that the critical points are in the domain. We don't really have to worry about that this time because it's all reals. So find the critical points. We do that by doing the derivative and seeing where it's equal to 0 and where it's undefined. We don't have to worry about undefined in this case, just where it's equal to 0.
You only have to do undefined under the zero.
Right.
The denominator.
Okay, so did you find the critical points? What'd you get?
Derivative and then.
Oops. Yeah, so what do we have? 2x minus 6. So we set this equal to 0. So we get a critical point at 3. Good. Okay, now, step 3, we want to make a number line. So I'm going to leave about an inch of space above. Just make a like a line here, and we're going to label this as f prime. Again, it's important to label that as f prime because later on in the next section, which we won't get to the second semester, but we're going to have second derivatives also. And I'm going to put on here my critical point, which is 3. And then, remember our domain? So just keep in mind, you don't have to put negative infinity to infinity, but I think sometimes it might help when we write our intervals, so you can just kind of put it at the end.
I swear I listened to the screen now.
Yeah.
No, like I'm not kidding. So listen to it last night. That's definitely.
It's definitely the same thing. Well, after I've taught it over and over and over and over again, I tend to say the same things. So I do.
For when you,
Yeah.
like when you first like introduced this, remember on B, how can you put the endpoint as negative infinity to infinity when the domain was negative infinity?
Which one?
B from like when we first started from the screen.
From the screencast? Which one?
That one. Went over x squared minus.
No, the domain should have been from -1, or so from negative infinity to -1. -1 to 1, and then
Yeah, we put open
So is it
we put open circles because that's where it's undefined.
So is it always just going to be on the number line negative infinity?
As long as that's our domain. Like if it goes from negative infinity to infinity. You'll see, there's some examples that it doesn't. Okay, now I want to pick a test value between negative infinity and 3 and say 0. 0 is an easy one. Notice I labeled this as f prime, so I'm plugging into f prime. So I get positive or negative? Negative. And then pick something to the right of 3, say.
We put it to F prime.
Yes, that's why I labeled the f prime. So whatever you're working with, that's what you're plugging into. 5. Do we get positive or negative? 5 minus 3 is 2. 2 times 2. It's okay. So now we're going to draw the arrows in. So if it's negative, it has a negative slope. So it's going to go down to the right.
There's a minimum.
And then it goes up to the right, so it has a min. Does it have any maximums? No, so there's a minimum. Our minimum is f of 3. Now, I labeled it f because our minimum and maximum values we get by plugging back into the original. So what is that? So 3 squared minus 6 times 3 minus 12. 9 minus 18 is negative 9. Negative what? Fine. And now what else do we need to write in? We need to write where it's increasing and decreasing. Okay. And all we have to do, because we made that number line, everything's right there for us. So where is it increasing? 3 to infinity. Do you prefer, you want me to just use parentheses?
Yeah.
All right.
We're gonna put a bracket on.
As opposed to a bracket. And then what about, we know infinity and negative infinity always need parentheses, right?
Yeah.
Okay.
But how do you know that it should be closed with a group?
It's just notation. It's just most books will use brackets. Okay, so all of this is our answer. So we had a minimum f of 3 was equal to negative 21, increasing from 3 to infinity, decreasing negative infinity to 3. Okay, next one. What's wrong? We're almost done? Oh, I have 2 more examples. We might not get to the last one.
Oh, you're doing the homework in class.
Yeah, I did. So what's the domain here?
Use your slip.
Okay. All right, what's the derivative? 3x squared minus 12. Okay, before 12x. So before I solve it, let's just factor it because it's easier to plug in when it's factored. So I'm going to take out what? And we're left with? Okay, set it equal to 0. What do we get for the critical points? Good. So make a number line, leave some space. And go ahead and choose test values and plug into where for test values? Plug into the derivative. So we're going to plug in here. So if we plug in a negative number, what do we get? Negative times negative, positive. Plug in something between 0 and 4. Do we get positive or negative? Negative. And plug in something bigger than 4. It's positive. So it goes up, then down, then up. So what do we have for our extrema? We have a max at 0, min at 4. So max is f of 0, which is 5. Yeah, just plug it in. F of, what's f of 4? Are you sure? You have no idea? 64, what do you mean you have no idea? 64 minus 96 plus 5.
It's not mental math.
Negative 27.
That's not mental math, is that?
I've done this problem, like,
Like
Lots of-
like, oh yeah.
no. It would take me a few seconds. Okay. Where is it increasing? Good, and then 4 to infinity, and decreasing. Perfect. Okay, so do you want the review packets today or tomorrow? Okay, well, here. Take one if you want one. I'll have them here tomorrow. I'm not expecting that you all work through it between now.
I'm good on mine.
So we have, what do we have tomorrow? I don't see Thursday. We have 3 days to review. Tomorrow, Friday, and Tuesday. But I have bonuses available, so if you're looking for me. Yeah, I made my AP classes not meet during blackout. If I'm not here, then find me in the faculty office or track me down. I don't know where I'll be. Chances are I'll be in the faculty office unless it's like my usual. Like today is Tuesday, so I'm going to be here, but I have bonus available. So I'll be here.
Is this where you go?
They stopped right where I left them. Take one or not take one. Just give me the rest and I will keep them for tomorrow. Oh, thank you. Any other homework?
Yeah.
Homework? Okay, guys. Yes, thank you.
So,
So do
Think
we
about
Oh wait,
do-
this is for the final.
Yeah, that's their final.
Oh right. I forgot that.
All right, guys.
So are we doing
I like
4.2 for homework?
Yeah.